Starten. Okay, seems to be running. Good. So the previous lecture, during the previous lectures, we have implemented the big int class, which allows us to represent very large integers using a custom object. And since including the last lecture, which was unplanned, let's say, which is on YouTube, so you can look it, but we didn't do much there, just the shift operators. But with everything we've done, plus everything you have to do during your homework, the class is more or less complete, at least with regard to the mostly common used features. There are a few minor things which we could add, but that would be like convenience features, so we can do that maybe another time. I was thinking that today we should start another utility class, and usually another type of classes which are very often used when writing program in C or rather C++ as we do, is a class which can represent strings. So as you know, in normal ANSI C, you only have non-terminated arrays of characters, which are very strict in what, not strict, very limited in what they can do. And so they are limited, mostly, let's say how they are limited. So first of all, you need to define which length you will have of your total string length upfront. So unless you know exactly how long they have to be, you will either waste space because you will allocate more than needed and then just fill up some of it. Or if you just always allocate a huge amount of space, you will be wasting memory. And another limitation, of course, is that if you want to, for example, concatenate strings or do any other operations, usually it means to creating a completely new instance of the array. So it's generally quite unpleasant to work with, if I may say it this way. So what most C++ frameworks offer is some sort of class which can represent a string and does all the memory management internally and allows us to easily operate with the string, to append to the string, which is usually the most common operation that we will be doing. So usually when you have strings, you want to assemble a path or write some text, and usually it is made by using some prefix, then you add something, then you add some more things, then you maybe add some suffix. So it's mostly concatenation of strings, which is done with strings. Another common application of strings is if you want to search something in a string. So this works with with normal null-terminated strings fine. But of course, if we are writing our own class, then it is a good idea to add some functions for this as well. And those can be arbitrarily simple or complicated. Because of course, in the simplest of all scenarios, we just have a function which can only search one character, which is useful in some cases, but usually what you would want is a function that can search for at least a substring. So a string that is contained within the outer string. And then the complicated things start getting complicated because, of course, once you are searching for a substring, you probably would like it to not be case sensitive. Of course, it depends on your use case. If you do things for Windows, you usually don't care for the case, as Windows neither for the registry nor for file system nor in most other IPC objects and other system resources is case insensitive. While if you do things for Linux, then Linux is by its nature case sensitive, so it will require a case sensitive search. In fact, the case sensitive search is much easier because then you are going just for an exact match. While with the case insensitive search, it gets complicated because you need to always check if it matches the current letter or if it would match the lower or uppercase version of the letter. For other characters, of course, it's triggered because there is no uppercase for the number or for the special characters. But for the letters, this needs to be taken into account. And what also one can then make even more complicated if one wants to is to implement a so-called wildcard search, which means that you can specify an incomplete string, then a placeholder, usually an asterisk, then another incomplete string, and have this way a match that contains of a couple of substrings which needs to be after each other and are separated by this wildcard character. The typical DOS syntax for wildcards is the follows. You can use a question mark to represent one unknown character or an asterisk to represent an unknown number of unknown characters, or rather unspecified characters. And if that would not be complicated enough, there is even one more level of complication with regard to string searches. Namely, you can use so-called regular expressions to search in a string. A regular expression is a string which follows a special notation and allows you in very fine detail to specify how the string you're looking for should look, and you have much more liberty than just having a wildcard for everything. You can specify that it starts, for example, with a certain prefix, then you have only numbers. You have, for example, you can specify between 3 and 5 numbers, and if it's a different count of numbers and it doesn't match, you can specify, of course, that then again letters should be or fixed portion. It's highly flexible. And for the purpose of this lecture, obviously it would be too flexible. So while case insensitive and wildcard search is something you can sit down and implement reasonably quickly, implementing a regular expression search is quite sophisticated. So we need a parser to dissect the expression, and then things start to be even more complicated. So we will not do that, but we should aim as a goal to at least have the ability to create to perform wildcard searches, because I said this is easily enough implementable in a quick session. Other functions which such a string class should have would be the ability to extract a substring from a string. So we have a longer string, probably we searched in it for some, say, 2 instances of something, and then we want maybe the thing that's in between, or we just know that the string is formatted a certain way, so we want from offset x to offset y. And such substring search substring functions usually just take the starting offset and then the length, and it's usually customary that the length can be also specified as -1, which means from the current offset till the end of the string, wherever it might be. The exact implementation of how it works with this -1 is, of course, up to the details. Usually, it's extremely trivial because the length parameter will be an unsigned integer or an unsigned long. So -1 actually evaluates to max value in the positive range, because an unsigned number obviously cannot represent -1 in the way binary representation of numbers operates. A -1 is binary equivalent to max value of whichever length your integer is currently. So the easiest way is just you take either the length provided by the user or the length of the string, whichever is shorter, and then don't even need like a special case if it's -1, then else, etc., etc. Other convenience functions in a string would be, for example, to convert the string to a either fully uppercase or fully lowercase string. Appending we already had. Another convenience function would be also a replace function. Sometimes you would want to, and for example, a good use case, when you handle paths on Windows, you use backslashes. When you have paths on Linux, you have forward slashes. And if you are using the Qt framework, they decided that their default path separation will be a slash, like on Linux. Generally, probably because like they are a multi-platform framework, so they were thinking, yeah, on pretty much every platform except Windows, it's forward slash. So let's stick with that. While probably most people actually use it on Windows and use backward slashes. So for example, if you would from your Qt part of the application have any path that you then want to pass to a native Windows API function, you would need to replace all the forward slashes with backward slashes, since Windows requires those. Qt is tolerant in the way that if you give any Qt function a path with backslashes, it will just automatically convert them to forward slashes. So it only is needed when converting in one way, but this would be a very real life example where such a replace function would be helpful. And usually the functions don't operate on a single character basis, but again, you can specify a string which will be then replaced with another string. And usually even the lengths don't have to match. So one could, of course, look, okay, if the lengths are the same, then let's do some optimized code path where we just really copy one string over the other in place without the need for a new memory allocation. But since usually we want our functions to be more generic, the default code path would be to start building a new string and then appending always paths up until the next found instance of the find string, and then instanting the replace string there. Another improvement to the replace function is of course the ability to specify a max count. So if you would say I only want to replace the first 3 occurrences or first 2, I don't have a good real life example of and why that would be useful, but I'm sure people will be happy to have such an ability. Usually I would say probably the most common use case is if you want just to replace one. And if you already and instead of making like a replace one and replace all, which by the way is how to an extent it is implemented on the Qt framework. There we have a replace one, replace all, and replace with where you can specify a number. And I guess they didn't have all the 3 because I guess they would have only have the normal replace. So the way it simply started was they started with some more specific functions. They made the generic functions, and the 2 are then just a wrapper for the final function. Usually in such classes you would not like make a copy of a function with a small change, but you would have a very generic function and then maybe some more specified function would just then call the generic function with some arguments pre-populated, so that the user of your class don't need to always specify all the more exotic arguments. Right. Another also very useful function on strings is the ability to split them, and how exactly this is again up to one's preference. The default option is that you simply specify a separator and then obtain a list of strings extracted from the main string separated by this separator. Another option might of course be that you have like a targeted split function that you want to split a string only in 2. So we want to find the first or the last occurrence of some separator string or character, and then at this place you want to split the strings in 2, and that's it. This is actually very useful when parsing various strings if you want, so that you can, for example, if you have a path, then you can split it into individual folder names by splitting it by slash or backslash. And in the case of splitting by 2, it's also useful, for example, if you have a file name and you want to extract the file extension, you would just split from the back by the dot, and then you will have the name itself and then the extension. So there are many different nice use cases, and I think already one of the last functions worth mentioning is a trim function, which what the trim function does is it removes white space characters either from the back or from the end or from both ends of the string. White space means characters which on the printer would not print but just move something around. So normal space, obviously, line up, so line feed, and carriage return, as well as tab, are the most common for white space characters that one would want to trim. And this is quite useful. For example, if you are reading some sort of text file, then you would want usually the user to be able to write the file and not really need to care, okay, do I need to write, for example, key is equals value, or can I write key is equals space value, or key space equals space value, and stuff like that. Of course, this bases on the assumption that for your value you would not have valid values or valid keys which are prefixed or suffixed by white space, but this usually is the case. And if you want to pass some file which and explicitly allow for white spaces to be part of keys and values, then you would usually include the keys and values in quotation marks to indicate that they can be whatever inside. But that is a bit of a tangent, so let's not continue on that. Yeah, and I would say we will start by creating a new project, and I will implement a graph skeleton for our string, and then we can start creating individual functions. Create a project. Right, one more thing that is probably useful, although I have always seen it implemented, let's say it like this, I've always seen it implemented in most of the string functions, but I almost never used it, which is a function that gives you the reverse string. So basically the string back to front. Why someone would need that is Well, no immediate use cases come to mind. Probably it's useful if you kind of would not have functions which allow you to search for example from the back. So then you reverse the string, search from the front, and then reverse it again and things like that. But we will of course try to implement a lot of different useful search functions, and so also including such which allow us to search from the other direction. We will call our class and our project xstring. There is one more thing which needs to be decided upfront. That is whether we want our string to handle only normal narrow characters, so 0 till 255, which can only represent the Latin 1 alphabet, or if we want our string to use Unicode, so wide characters, meaning that they have about 65,000 values. Plus, there are certain Unicode characters which actually kind of are made up of 2 characters. So then you are with your value space at 4 billion. So as I guess it becomes already apparent, you can use you can represent all the languages, all the characters from all the languages of the planet in one huge Unicode. That's why the name Universal Encoding character space. So, and by the way, Unicode also contains a huge amount of non-textual characters. So you have all the different smileys have Unicode values. You have different arrows, different types of dashes. So you can, to a significant extent, format your text without needing to actually insert any things there. Images or things. I said smileys and stuff like that is part of the Unicode character set, and which is being extended every year by a few more entries. So it is quite useful. But of course, it requires more storage space, and there might be Windows APIs which would prefer a non-Unicode input. Although I think the most of them all take Unicode, and the Windows kernel itself is Unicode exclusively. So if there are any API functions which require just an ASCII string, then usually these are just some more exotic libraries which don't have modern equivalents. So now to decide the way how to implement the string, there are 2 ways. Basically, one is that we just decide we want wide characters and that's it. Or the other option is that we would want to implement the whole class as a template, which means that we can specify which character we want to use as a character. And I think since our previous class was a rather simple one, split it in 2, and not a template, it would be probably better if we now need to learn how template works, we have more exercise with them, create a template class for that. So here I will rename, of course, our main CPD only, so that we don't use the file name for our big string. But the most important thing about such a template class is that unlike our previously implemented big int, it will only be one file. It will not be split in a header and a source. The reason will be apparent soon. Page. And so we have here our links, and let's see what we want. So we said we want the ability to split, which poses another challenge, namely how would we return a string split up in other strings. So generally there are 2 ways to do it. One is to have another container type, which can then in turn contain well, our string instance of our strings, for example, a std vector would be such a container type, which would be a good candidate. But then, of course, it requires us to use the STL library, and we already have a string class. So I would say that we would try to do it in a, let's say, less convenient way, which is basically that you have a function which you call, and you get one instance, and the function takes an argument as a reference, which it will internally advance, which will be an index. So basically, you need to call the function each time for every instance in a string, and the last time you call it, you will get an empty result. So I think this will be a more elegant way of doing it. Another thing which we will need to do if we want our string, well, the other thing to decide about our string is whether we want it to have a copy on write semantic, as I think we remember we used on our big int, or if we don't want that. And I think since, if I remember correctly, we used the last time the SED atomic class to implement the reference counter. Here we would either do this using Windows internal API functions, or we would use decide to implement a string without copy on write. And in fact, the string implementation of the standard template library is such that they do not support any copy on write. For now, I think we will start with creating a data object to contain all the data, but we will not yet implement the reference counting mechanism. Actually, it might be a good exercise for home, since we had it in the last one, so you know how to do it. And upgrading our class to such a class would be, I think, a good exercise. So I think this will be our plan. So let's start. So when we create a template, whether that is a template class or just a template function, we start with template. Then we specify a type name. Well, the letter or the string that you use for after the type name is up to you. It is kind of a placeholder which you will then later use in your template element. You can specify more, y, etc. But of course, in our case, we only need one. But just to remember, you can have multiple multiple types specified in a template. A use case that immediately jumps to mind for such a template would be the STD map or any other map implementation. A map basically is like an array, but instead of indices, it uses keys, and those keys can be anything. So, well, almost anything. There is a certain requirement that the key need to be sortable, need to be comparable, and stuff like that. The details depend, of course, on the implementation the details depend, of course, on the implementation of the map itself. But the general idea is that the keys usually can be strings, numbers, doubles, and other objects, complex object. You would create a complex object which represents a IP address and a port pair. So really anything that you implement the right operators for can be a key. And there, obviously, you have an object which takes two template parameters, one which specifies which type the key is made from, and the other one which specifies which type the value is made from. And of course, you can concatenate such objects. So you can have a map which has a string as a key, which contains a vector, which contains again strings, for example. So there is quite a high flexibility when using template objects in general, which is what makes the standard template library so powerful. Let's continue. The template class cx string Okay, so let's first start to bundle. Let's also create a private section. Private section. So here we will create a helper object which will hold all our data. SX string. Generally, when creating such objects, I like to use the exact same name, just with a S prefix instead of a C prefix. SX string asterisk M. I will just call it M, like for member. Semicolon ISF. We want to initialize with null, just in case, so that everything is always initialized. usually we can expect to have constructors which will initialize things anyways, but I think if you are using a modern compiler, it is a really good practice to initialize your variables directly where you define them, especially because for more complex types like a string or any other class which you would have added as a member to your own object, and they would have their constructors called automatically by the compiler anyway. So kind of having manually to initialize the machine type variables while letting the compiler automatically initialize the classes and objects is kind of, let's say, I prefer if everything is done the same way, and it also then avoids prevents you from making errors, or at least not prevents, but it reduces the likelihood of making errors. So of course we will need a constructor, one that creates just an empty string, so it will not do anything. Another thing which is very useful is another constructor which will take a typical zero non-terminated string, so const t asterisk. So we take instead of writing const char, we write const or const v char, we just write const t. In fact, when we are done with our class, we could in principle invent an own character object. And the nice thing about this template is that such an object, we are not limited to say, okay, we can take a character, we can take a short, so Unicode character, we can take a long, or something, but we can have a whole object which represents one single character. Usually that would be total overkill, but for example, Qt actually does it this way. And at this point, one thing to note that is probably not worthy, why it would actually be useful to be able to also have a long as a character type is that while on Windows the Unicode character set uses short, so 16-bit characters, and in special cases of the very extended Unicode character set, it then escalates things to use two characters together kind of as one, which is problematic if you kind of want to advance the string always at one character at a time. You would have special situations where you would actually need to advance two at once, but those cases can be ignored because usually when you are doing things with strings, you will either search for entire meaningful phrases, or you will concatenate entire meaningful parts of the string, or you most often just search for the Latin one portion of your string. So some backslashes, maybe some path names, which can, of course, on modern operating systems be Unicode, but I would be of the opinion that it's better to keep everything just Latin one for interoperability reasons. But what I want to say is that Linux and I think other Unix like OpenBSD and probably Mac, although I don't remember how it is on Mac, to be honest, are just using a long for their vchar_t data type. So maybe I will write this quickly down here as a comment so that I remember on Windows that you will vchar_t short. Let's also specify the compiler, because in principle it's not necessarily it might also be up to the compiler what it picks. So you could kind of compile your own Linux and then tell it to use Windows type of characters. But so let's do here specific Linux and other Unix style systems, comma the GCC, comma so if we implement our class explicitly with the ability to specify whatever we want, we could, for example, on Windows write a function which would use our class to read a file that was created on Linux and uses the Linux encoding type, which would be quite convenient. Although well, just one more thing to be said about strings and saving strings to files. While Windows, of course, doesn't like standards and is doing everything their way, you can find on Windows files which are just saved as Unicode as this short, unsigned short characters to disk, saved to disk directly. But what is usually considered the best practice is to save text as UTF-8 encoding, which means that it will write most of the characters just as normal single byte characters, just that not every value from the Latin 1 character can be represented this way. There are a couple reserved bits, and if those bits are set, then the next character is taken into the evaluation as well. And usually you only need 2 to represent most of the Unicode characters, even on Windows, but there can be cases where you need 3 characters and so on. So there's a rather complex parsing mechanism which allows you to read UTF-8 encoded strings from a byte stream and can generate a Unicode, be that 16 or 32-bit string as an output. And since this is a standard, then of course if you save your files in this format, then you can read them on any platform without issues or having to take into account some encoding scenarios. Whether that is something that I would say one should always do, I would say it depends, because if you really just work on Windows, then the conversion and reading step, and if you read and write a lot of data, then it is kind of wasteful. So it might be more advantageous to your use case if you want to save some binary files, especially if you want to save some binary structures, to just save the data in the encoding as used by your application internally. Whether we will take a look into UTF-8 in detail later during the lecture course, we will see. Might be a good homework to write a parser, but we will gauge that on basing on your level of expertise by implementing it here. So let's continue with our constructor. So we specify our arbitrary type, then we specify a pointer, pointer string. And then what also is quite good to have is a size team view length, which by default is -1, so that we can, if we want, specify a length. So some Windows APIs might return you strings in a different format than a null-terminated string. They would use a Unicode underscore string or an ANSI underscore string structure, which is defined in the Windows headers, which contains of a buffer pointer as well as 2 length parameters. One specifies the maximum length, so the amount of allocated memory, and the other one specifies the length used by the actual string. So you can allocate a lot of memory and then just use a portion of it. And this is what is used by the Windows kernel internally for pretty much every string operation. And there are some APIs which give these structures back, where it is not guaranteed that the string written to the buffer will get a terminating null character at the end. Usually they do, but it's for some APIs it explicitly says it's not guaranteed, or it is not specified. So this is a easy error source. So if you see, okay, for you it works, it always is null terminated, and it worked for the last 10 years, and then there's a Windows update, and then it might stop working. So it is useful if you're using such APIs and you get an explicit length of your string, even if your string is not terminated, to just explicitly pass the length to your constructor so that it knows where to end searching for the end of the string, so it knows how much data to copy. So this we will have to fill, so to do. Then the next thing we need is a copy constructor. So then copy the name. A copy constructor is one which takes an object of the same type, usually as const, equal to other, and it creates a copy. So copying strings is obviously something we would want to do quite often. So we will have a copy constructor, and I think this is already all we need with regard to constructors. we could add, for example, one which allows us to convert numbers to string, which actually is quite a common use case. But what is kind of probably a better practice is to have like a static function which takes a number and then returns you a string as a copy instead of using a explicit constructor for that. From a technical standpoint, it doesn't matter, but it, I guess, makes for a more elegant UI. And also, at some point, if you want to have a lot of different ways how numbers can be passed with different representations, then you might run into situations where your constructors will not be unique enough. And if you instead have just a from number, then you kind of really say, okay, this will always be from number, and it will not, even if you pass it a pointer, it will know, okay, I want to have a number out of this and not, oh, it's a pointer. It might be a pointer to a string. Let's read the memory into the 0 and then it crashes. So if you want to avoid such scenarios, it's better to have the static option, and especially if we implement a copy and write semantic, or rather you implement it as a homework later, then the overhead is extremely low because we are just copying some references and not really duplicating the whole string. Okay, last on the simple things, let's maybe look on our structure, what we want to have there. Obviously, this is it's really quite analogous to what Windows does with its own structures. We will have a pointer which contains the actual data, so p asterisk p data. Then we want to have something that contains the length in characters. That is going to be your length. We could in principle initialize here everything with 0, but I don't think we will have a scenario where we call new on them. Nice, yes. And what we also would want is the total size. So in case we allocate more memory than we need, we would want to know how much it is here. An important thing to keep in mind when operating with the string functions is that what is the increment of your size variable. So for example, the Windows object uses actually the length of the memory, so not the count of actual characters. While for the most things that people use strings, it is more interesting to have the length of characters. So this is why here we will keep our length in characters. Characters, however long they might be, and we'll have a second size variable, size t, the size, which will contain the total length of memory we have to use. And we actually could, just for fun, store this value in bytes. So we will need to do some conversion wherever needed. And of course, there will be here a to do. Add a or copy on write. Copy on write. But this is not a to do like that. This will not be today's homework. Today we'll start slow. And I think a bigger part of the lecture will probably need to prepare everything that is needed. Right. What also would be very good is of course an assignment operator. Equals the assignment operator returns, if I recall correctly, a reference on itself. I think it does. Let's just assume it does. If not, then it will complain. So some operators return just a new object, and other operators return a reference on itself. Const other. Let's use the large O everywhere. Other. Return. Everywhere. Go. 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 Good. They would have this, although this will be plain to compile, so let's go a little bit actually this, so that at least compiles time. And what we would also want probably is a look at we will do that later. We'll do it the same way as we did it in the Xint class, namely we will create one general shared compare function which just does comparing of any kind between two strings, and then returns 0 on match and plus and minus 1 depending on which string is larger. Now, what is considered for a string to be larger is probably very much up to debate. One general issue is that usually if you convert numbers to a string, then the larger comparison will not work correctly. So you will have rather numbers. So typically it's like it's sorted kind of by character only. So you have like 1, 10, 100, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So it kind of does not correctly sort things, and usually for strings this is not necessary. The most useful string sorting application is when you have the aforementioned maps or other things where you need to have an order which is reproducible. So there you would, so what you basically just need is an order which always will be the same, but whether it makes sense from a human standpoint, it's irrelevant. It only has to make sense from a computer standpoint and be unique. Right. So that much to this. And I would say if there are volunteers, then someone could already start implementing the constructor here, and if so, but only if you feel already skilled enough. If no one wants to volunteer, then I would now also implement at least some helper functions so that we have at least a string to begin with. So let me know if anyone of you wants to create this constructor and then need helper functions, or if I should do it for you. Okay, since no one is saying anything, I assume I have to do it. So let's start with a function to create for us a new data object, because that's always a good thing to have. Okay. And it will take as an argument length, new length. Let's call it new, which will no, it's called capacity, because I don't want I don't want to have variables which have the same name but slightly different meanings. And if we would call it u-length, then it would kind of suggest that we will copy it onto the u-length of our m pointer, but that's not the case. It will be divided by the size of bytes in a character and copied onto the size, while u-length will be 0. So let's call it capacity. Because if I would take size, then the assumption would be that that it is in bytes, while we want the capacity. We'll write it as a comment in characters, in chunks. Right here. So and now one more thing which we could think about, but I think that complicates things too much. So what one can do in principle when creating an object, a structure, which has only one member of unspecified length, let's say, is to make this member the last one, and then just allocate all the memory in one go. Which kind of saves us on memory operations. So maybe we should do that. Plus, you would learn something new. So a small change. Then we have here key. So basically, what we create is kind of an array of unspecified size. Oh, sorry, I think it should be zeros. Of zeros actually. Data. And while you cannot assign to it anything, you can access it as an array, and this way all the data are in one memory block. So here, make a size int variable u size, I will just call it ulen. It's like something different, which will be size of string. So first we need, of course, enough space for whatever is in the header portion of our object, and then we add to it capacity times type of t. Of course, this might be bigger, and let's say this will be the capacity including. So let's say we try to always include a terminating null. So always +1 wherever we can, and wherever it makes sense. So now we will allocate a new object. So first we should of course destroy the old one. So I will add here a destroy one. Of course, later the destroy might be more a detach. No, let's call it release, because that's like destroy implicates that it really definitely destroys something. Detach kind of means that it will just detach and not destroy. But release is kind of, it either releases the reference or it releases the resources, which means it destroys. So which we will call it release. By the way, when you would in future write something for the Windows Component Object Model, there the different objects created also have a function called release, usually to get rid of them. Yeah. So this is actually quite a nice thing to do. So first we have to release whatever might there be, and let's first do the release function. So if m, then now we can either use free or delete, and whatever we use then will depend on what we use to create object. But I would say, since I think in the last object we use new, so here we then we use free. So here we will use sorry, new, and then we use delete. So here we will use malloc and free. Free m, and then just we also need to assign m to be null, so that if for some reason the release is called twice and it equals null, it will not try to delete something that has already been freed. So free after double free or use after free are is a common class of errors, and this we can put here into our destructor without any further checks. So this is already safe to use as is. And we have here our release. So now we know our endpointer is free to use. So we can m is equal. We will need to do a typecast, since unlike new, malloc is always returns the void pointer. But the advantage of malloc is that you just specify the size, while with new you specify the object, so the object has to have a definite length. So here we wouldn't have any other choice, and we can specify the length in the hole. And now m we initialize the hello. This data does not work. We have a typo. No, xstring is fine. This is there, and this pointer should be working. Washed with the video without even. So length is 0. I can see uniform working. So length is 0, since when we start the string is empty, but m size is equals this amount. Or actually, it probably would be more computationally efficient if we just call this size. And make this plus size, because we need the value of size here to assign it further down, and multiplication is computationally intensive. And in the size, we also will add here in bytes, and so that we know explicitly what our thing is doing. And right, and last thing we could do is we could initialize everything with zeros, which probably is a good idea because it helps us avoiding bugs, even if it is somewhat slower. We could actually use the if and hash if that is defined underscore value. It's a preprocessor definition which is set in all projects which are here set on debug. If you set on release, the debug will not be present, and it allows us to specify that we want to initialize a string when set and data 0, and post. That we want to initialize it only in the debug build because there we want to catch errors, and in the release build we don't. Although we could do another thing for the release build, but we should do it anyways. That is set the first character to null in any case, because this will ensure that we don't have any problems if we accidentally pass this to something without having initialized it further. So actually we could even remove that, I think, because the way you will see things in the IntelliSense and in the locals in the debugger is that it will terminate the display of a string type variable as soon as the null is encountered. But let's leave it here just as a demonstration of this preprocessor definition, how it works. I think it's fun. So we have released it, we have created a new one. Okay, we are happy. I don't add here any comments of what to do in case of the copy and write use case. That will be for you to figure out as one of the later assignments. So we have our thing. So now here, the first thing we need to know is to know how long the string is. As we said, just a lowercase infinity. There is another definition where the whole size t is uppercase, but in this case we have lowercase. So one thing we will need is a function that will count for us the length of the string in case we have not specified a length. So let's edit here, or maybe let's edit the private function. Yeah, let's edit the private function. Size underscore t. Actually, it can be a static function. A static means that you don't have access to this object. So the function is kind of behaves as it would be just outside of the class. But of course, if you do more advanced things, it doesn't, mainly because if you would want to access private or protected members of the class, you couldn't do it so easily from outside. But if you have a static function on a class, then it would have access to everything. And there are use cases where you would have such a function and give it a pointer to an object of their own type instead of this, and then do things with it. For example, when you're using Windows APIs to do things. I like starting flattening out. So we will call it xstlen, which will take a const the asterisk out, and we will need to implement it. But for now, we can 0 and then we'll do right. So first we check specialty for if this is equals to -1, then this equals x then, and I will call it as removed. One thing to keep in mind with this implementation is that it is not fault tolerant, because we only then evaluate, only then look for the terminating null if we don't have the length, and we might have a scenario where we would have zeros earlier. But actually, this is useful because there are methods where you actually have like a string of strings. So we have a zero terminated string followed by a next zero terminated string followed by a next zero terminated string, and then you have another zero. So kind of like once you encounter a string of length zero, this tells you that there are no more strings in this memory, and then you should terminate. So if our class is actually made such that it ignores zeros and actually allows us to use zeros in our strings, unless we use a function invocation that relies on the length of the length being extracted from the string, only then it takes loop. So it kind of is more flexible and more powerful. In fact, the Qt strings as well as the str strings work both this way. So if you assign a string that contains 0 and specify a length, then it will just take the zeros and that's it. So maybe I shouldn't say it's fault tolerant, but maybe I shouldn't say that it is not fault tolerant the way we do it now. It's actually just more flexible, but the flexibility can introduce faults. One common fault would be that if you compare a string with a terminated null with a string without a terminating null, or rather with a string which was created and a terminating null because you passed the wrong offset have been included as a portion of the actual string, and then you compare it to a string which you just compare it to one created implicitly from a C string which doesn't have the excess null at the end, only has 1 and 2, then it kind of looks to you like, okay, it should work. The debugger shows you that the strings look the same, but then the compare function says, no, they are not, because the lengths are different, so it even fails before it even starts to do the actual comparison of the individual character. So this is something to keep in mind. That's why I mentioned it, but we will keep the more flexible option here. Okay, and now since we already have the length, we can create our object. Yes. So we can really what to do. And yeah. Okay. And then we specify reset capacity. So by default, we'll just create the length that we need. Only once we start growing the string, for example, by appending, we would then want to create imagine one thing, namely that we might want to keep a reference to the old data object. So we probably should improve on this function slightly to make it return a new one and to call the release manually. So this will be a function which returns the pointer, can be static because it does not modify anything on the existing state now. And here instead of m, we will actually could we use the name m, but that would be confusing. So we will define just call it p for pointer. I could also just write out ptr, but it doesn't matter. I mean, C++ is very tolerant with regard to how you decide to structure your code, which on one hand is nice, but on another hand, if you have more things to decide, you have to decide up front, because if you decide to change it later you might want everything to be consistent, although you don't need to. You could just change your coding stack from one function to another, and only people that read your code will complain. The compiler will be fine. So now that change the function, we need to assign m is equals. And we don't need a release because we're in a constructor, so we know explicitly that that the m was null before. So copy it, and then we could add one security, namely check whether this isn't null, because we could, in theory, say that we can use this function to create to pre-allocate some memory by specifying null comma a length. So this is something we might want. So this thing here should internally, by the way, check whether the pointer is null to be fail safe. In case we specify null and no length, I'm sure people will do that. But usually this will be fine. So we have m, and now if is true, so if there actually is a string, if the one string has been passed to us, then m equals n. Otherwise, we only pass it here as mentioned for capacity, which means that it will be only passed used to generate the right size, and length itself will remain 0. Okay, and then of course I've already copied. What were the syntax? First where, then what? So n underscore data. I must admit then IntelliSense is not working right now, is a slightly bit annoying. In CR. Okay, that's it. at least at this extent. Now we only need the xlength function, and since I was already talking for a whole hour, I think it would be time for at least one of you to try implement something. And I think this xlength function is not very difficult. So who would like to implement it? But if no one wants, then
can you hear me?
Yes, I hear you.
Okay, I can try.
If you're a volunteer. So I will just need to figure out how to get you connected, because I said I'm using a different computer here. So there are a few technical difficulties to work around, and you will be redirected through a bunch of VPNs.
Well, I rolled with you, so I could share the screen as well.
Sorry? That would also be an option, but let's quickly try whether it works easy enough. So you remember all the IP address where to connect to, or shall I tell it to you again?
I need it again, yeah. So I need to open the VNC viewer, or,
yes.
Yeah, okay.
The IP is this one. The password was, I think, 16.
Uh-huh.
One I wrote in the chat. You don't want the password on YouTube.
Yes.
But wait, two things. First of all, you need a port, which I forgot to tell you. Plus, I need to reconfigure. Oh wait, that was very difficult. No, let's maybe do the screen sharing from your end, because the VM here is within a NAT. So even if I had a VPN to my usual location, that will not work. So I will stop my screen sharing here. Bildschirmfreigabe beenden. Yeah, then I will record your screen, if that's okay with you.
Yes, yes.
Okay, I double stop them. I think I need to enable it. Freigabe mehr and thank you. Let's try if you can share the screen.
This is where I need to click it. It's a long time ago since I shared the screen.
On the bottom in Zoom is next to security is a Bildschirm freigeben. It's like a square with an
share screen. Yeah. Okay. Let's see. I think this is the one. Yeah. Do you see it, or?
Yes, I just need to put it at the right place. How do I close the chat window? No, not closed. So almost. I need to place it in the right corner for the recording. Good enough. Yes.
Okay. So you want me to include C string type?
I don't think you should not need to include X string. Why is it complaining? Does the header have a typo?
Okay, I think it's just.
No, it should single quotes. Yes, now it's fine.
Yeah.
Right. So you could first write a small test case where you assign a string and tell it the length, so that we don't need the xstring function. And then, as the next step of that, you will create the xstring function.
Okay, I need to create a string, a character, a string, or
you could create now. You could start directly with xstring, just xstring.
Okay.
Then you specify the name, and then you specify just a normal C string in quotation marks, and then you just type the number of the count of characters there. That reminds me, I forgot a small detail, but we will fix that later. We forgot to always add the terminating 0 after the mem copy, but that's a small detail. So
well, should I add it in the header?
do it, yes.
Or?
Just go to the xstring header, and then after the memcopy, add a new line, and assign m arrow p data from. Oh, memcopy is wrong. We need to. There are two bugs. We need to. So here you take p data from view length is equal 0.
And p data
So
view
square
length.
brackets and square brackets.
Yeah, square.
Not from 0, from view length.
View length. Yeah.
But I also included a bug in line 21. It should be view length times size of t. No, not here. Here it's fine. In line 21, it's my bug. You did it fine.
Memcopy mp data p string view length size of p
times size of t. Yes, or size of t times view length. It's the same.
Okay.
Yeah, perfect. Yeah. Okay, now we can go back to our main, and then you pick a name, test1 or something.
Yeah, it's usual.
String is fine, but we should not use assigning right now. We should use the constructor, so just open brackets.
Okay.
After the variable, you open round black brackets after the name. Here. Then you can write the string in quotation marks.
I need here just to, or no, I just misunderstood here. Okay, I need something here.
No.
He's complaining.
We will try to compile it to see why it's complaining. Just write round brackets, normal round brackets after my string.
Okay. And now I have to create this string inside. So the character, the white string, I guess.
No, you remove the curly bracket. You just need a semicolon in the line on top, and then inside the round brackets you can write quotation mark, test, quotation mark, comma 4. Test.
Comma. I can barely hear you because I guess my.
Just write test.
Yeah. Okay.
And then comma 4. After it. Inside the brackets after the quotation mark.
Okay. So I just missed what is my goal here. So I created this string inside the constructor.
First, you want to create an instance of X string such I think the S is not capitalized. That's why it's complaining. And then
I think it's this.
Oh, sorry, it was CX string. CX string. CX, and now the S. Such as.
I think it's
capital. No, capital C, capital X, capital S, and then string. Capital S, yes.
I think it's not like this.
We will see why it's complaining.
CX. Okay, it's X string. Yeah.
Okay, and now just add the 4 after the comma.
Yeah.
And press 1.
Okay, to tell him.
Not one. Is it a 4? I'm sorry, I have a 4K screen on my laptop, and this part of the screen is like not zoomed at all, so I don't.
But it's already defined here, -1, or isn't it?
No. That was good. The difference magnification. A bit more magnification. Otherwise, what to do? Here should be comma 4. We want the length of the string that you have told it.
Okay, for 4.
Yes, for 4 characters.
Okay.
And now press play. Let's see what it is complaining about.
Okay. Train and return type is not allowed. Okay. Let's see what it is. It's complaining about this assignment pointer.
I will. But there are a few bugs. The I is capital. I will quickly check. I will quickly switch to my screen maybe and check. I will quickly switch on my screen to, on the recording, but not on the channel. If that's fine with you. To see if my actual version compiles or if it complains about
maybe.
some.
Maybe I copied something wrong.
Just here repeated text.
I think here's something. Yes.
That's okay. This comma 4. If I run it, oh, it might of course complain. I know what it will be complaining. I think it wants you to specify. Yeah. Okay. So first of all, it wants you to specify the graphic type. And then it will probably. So we have a few minor bugs. So I will switch to my screen and fix all the bugs. The machine again, which
I should stop share.
Let me screen. Which machine is the correct one? Yeah. Okay, so first of all, here I forgot to write the type. Was one bug. Oh, I forgot to write struct. That's embarrassing. Trying again. Right, almost. This was not correct. That should be clear. Anything else? One more. Depending on the compiler setting, this could work implicitly, but let's specify here the type. Did you have can you run on your code and see if it compiles with the changes? Then we will switch to your screen.
No, still the same problem.
Okay, when mine works, then let's quickly, you can start your screen sharing, and then we will see what's wrong with your code.
Okay.
I double stop it. Now we should be able to share it. Right.
I changed the main as you did, so I think it's correct.
Yeah, okay. Press play. No, it's struct also.
Just the button is a little bit obscured because of the.
Is it actually?
Let's see. Okay, nice. So I changed this one, the 0 and the.
Press play again. I see something. There was one M that you forgot in line 67. It should be P, not M. P data it should be P data.
P data, okay. Just P data, okay.
Yeah. No, sorry, P arrow P data.
Okay. Sorry.
Okay, play again.
Okay.
Double click on the first arrow from the list, line 62. Wait, so tests. That should be fine. X.
Do
you have a typo maybe in the X string? S. Yes, you have a typo. I think scroll up.
X string. Okay.
You have no S X string. Okay, did I write it this way?
Maybe here.
Okay, I wrote it this way. Fine, then we did it this way.
Okay.
Why doesn't it work for you? Why it works for me?
Huh. Should I maybe start from up here and see X string length? No.
No. Let's scroll down. It must be something with the function. The function is static. We create the key. We convert it from malloc.
I created here the struct. Data PU size.
Yeah. S malloc. You have a semicolon wherever it is needed. I have no idea why it doesn't compile for you. That is really odd.
Sorry.
And it's really complaining about line 76 as well. 76. Scroll up. It must be something with the structure definition. Struct explain. Size data. It might be something obscure. Can you go to the main function? Okay, but we have the same include, so that's enough. Go back to the X string.
X string, where's X string?
We have like some org. Can you check the error list? What other errors we have? Maybe such errors sometimes occur when you have like when we open a bracket and then forget to close it where appropriate.
Yeah, but it's usually the IntelliSense to tell me, or with the red mark.
Wait, scroll down. I may see something. Yes, I see something. Line 61. You have two closing brackets. It should be only one on the very end. Click play.
Okay. Yeah. Let's try it. No, still. Okay, just one arrow.
Double click. Void.
Maybe I have to put it here. A semicolon.
Yes.
No.
Pre-semicolon M.
If M.
Completely right. What?
Please.
I'll restart the screen magnify again so I can read the error that you get with the mouse. With the mouse. Next thing release call of non-static member function. What?
58. Line 58. Okay.
Yeah, go to line 58.
This release.
Yeah. This you should remove it. I changed the code. In my code, the release is not there anymore.
Okay. You moved this up there. Okay. Then in the destructor. Okay.
Now we can play.
Okay. Okay. Still, we must return a red.
Yes. Okay. Return P. Just add in line 67. Return P. Click. Yeah.
Okay, now it's working.
Perfect. Now we have 11 minutes to implement the exercise function. So now you change here the example by removing the comma 4.
Yeah.
Yep. And now you want to go.
Just any character.
No. You remove the quotation mark. We need it. Yes. And now you need to go to X string H. Just one comment. I will rename the structure to SX string later before I upload it to Moodle. But for now, let's ignore it. And you go down to the X strlen function.
And then some function here.
Where it says to implement. We want to implement the function. And the idea is, so I would say first you could check if pointer is null, then just return null. That's like handling the error case.
Or I don't need this now, just add pointer.
Yes, that's fine. Return null.
Okay.
And what you now need is a loop that will iterate through the whole pointer by in increment of character and check and count by iterating, and then check whether it encounters a null, and if it encounters a null, then it should break and return the count it counted to.
Okay, the character I'm loading from the CX.
No, you count the ones in the argument. So pointer PTR.
Ah, okay. See. If I is okay, I need just to think about it. Smaller than PTR. I plus plus is this kind of right? Let's see. I plus plus I pointer till pointer. Yeah. But is it working like this? Because this is an integer and this pointer is another.
That is not quite what you want.
Yeah. Size of.
No, also not. You don't know how far to go. That's how the trick. That's your story. What you need is you need to. So what you could do is create a loop that just starts with increment in I. Which create a loop where I starts with 0. Then you make a comma, not a semicolon, not a comma, sorry, but a semicolon. Then delete the content of the condition for now. And then another semicolon. So loops, you need semicolons. And no, one more modification. Let's move I outside of the loop so that we can access it. So not the whole thing, just the int I is equal 0. Write this before the loop. And for completeness, we would want not int, but size underscore t.
I want to start with 0.
Yes, we start with 0, but we would want the type to be size underscore t, just for completeness. For
okay.
Symmetry. Usually we won't have strings larger than. Okay, and then you can add. You can make the return function. No, you don't need any initialization here.
Yeah.
And in the condition, you write point. So what do you write? Asterisk pointer plus plus. No, not here. In the next one.
In this one.
Asterisk pointer plus plus.
Okay.
So what this does is it takes the value at the address pointed by pointer and checks if it's null, because the way here the loop the for works, it checks if it's null, and if it is not null, then it will continue running the loop, and if it's null, it would break the loop, and
so it's
plus plus will advance the pointer to the next character.
The next character.
Next memory address. And
so this is like a comprehensive list or something like similar to Python.
Like what?
Like similar to a comprehensive list.
I hear you not very well. To a what?
Similar to a comprehensive list in Python, like in close loop.
I'm not so deep into Python. And now we only need to do two more things. First of all, we need to end the loop without anything. So just write a semicolon. So we kind of have a loop without a body, and we return I, which is our counter. We could kind of rewrite it to a while loop, but it doesn't matter. And now when you run it, it should work. We don't have a test code. You could put a breakpoint in main in line 12.
Okay.
You press F9 or you click, yeah. And then you run. And then we should end up in the breakpoint. Once it ran. Yep. And then we can, in the locals panel on the bottom, use the small arrow to expand the content of my string. Okay, and this one as well. And it didn't work. Our counter didn't work. Why did our counter didn't work? Let's go back to our X. Oh, I know why it didn't work. You made a small mistake in line 81. It should be an exclamation mark pointer. If it's not null.
If it's not null. Okay.
Okay, now it should work. Let's rerun it. Yes.
Okay, now it's working. Seems like
so. It's working. Yeah. So since we only have 4 more minutes, and we did not have time to do much, so I will. Can you stop screen sharing? Then I will switch back to mine.
Okay.
So right. So since we did not do much past this basic setup, I would say a decent homework, which should not be too difficult, I think that it's here, is to implement those two functions: the copy constructor and the assignment operator. And just a small tip: it's very easy because you just need to implement the assignment operator and then use the assignment operator in your copy constructor in a clever way, and you're done. Or you could write a function assign which takes an argument other and then does in those two cases the appropriate operations. And keep in mind that with the constructor you don't need to do a release, but with the copy one you need to, because otherwise you will end up with a memory leak. So we would not want that. So these two things are the homework, are easy enough, I think. But I wanted to fix this, so here times and make this also a zero terminated. Zack, zack, and with 0. Right here. I will rename this to S X string, so I will add the capital S in here. I kind of mistyped earlier. And I will call this function either the way just include it or my way, doesn't matter. It will be very similar. And upload the things to Moodle probably today in the evening, together with the lecture at, which is at 3 o'clock. And since we are literally exactly out of time, then let's see each other later today, at least those that come to the lecture as well. And good luck with your homework assignments. Bye bye.